Hello, Assalamualaikum to Madam Jalina, our lecturer for ECW568 Environmental Engineering Laboratory. So my name is Muhammad Fazli bin Jaafar from group 6A3A. So the purpose I'm doing this video is for the mini project, which is my group are required to prepare a purification system. So for my part, I'm going to prepare the synthetic raw water to prepare a 1.5 liter synthetic raw water. So the apparatus or the material that are required for me to prepare this synthetic raw water, which is the first one is 1.5 liter bottle containing the bottle, and then the second one is the funnel, and then the third one is the sample of soil together with the spoon. So the step that I need to do is simple. So I put this funnel on top of the bottle. So I will take a full spoon of soil and I will put it in the bottle. The bottle and I will shake this water bottle. So this is the color of the synthetic raw water that I have already prepared and going to be used in the purification system prepared by my other group member. So this is all for my part. Alright, that's all. Thank you.
Hello and Assalamualaikum warahmatullahi wabarakatuh. I, Muhammad Roman Hakim bin Johari, will now demonstrate the first design of our water filtration system. So in front of me are the all apparatus and material needed for our design. The first is the plastic container, 5 cm height of fine grained soil which will be put into the plastic container, 5 cm height of gravel which will be added after the fine grained soil, rubber bands, ruler, knife cutter, marker, and a piece of cloth. The first step is place the plastic container upside down. Use a marker and a ruler. We will make 3 circle marks with each of the mark has a diameter of 2 cm. All these 3 marks will be made at the bottom part of the plastic container. So as you can see, these are the 3 circle marks. Place the piece of cloth at the outside of the plastic container below the holes. Use the rubber band to make it fix. You can add more rubber bands for an extra grip. The second step is to make the 3 holes. Use the knife cutter and just cut and follow the marks that you have done earlier. So this should be the hose. So repeat this step to make the next two holes. Create a marks at the plastic container with 5 cm height and 10 cm height. The first 5 cm height is for the fine grain soil, and the second 5 cm height is for the gravel. Add the fine grain soil into the plastic container. Add the gravel into the plastic container.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazib bin Rozani. Now I'm going to demonstrate on our second design of water purification system. So first of all, I'm going to show you the apparatus and materials needed for our second design. So basically, the types of materials and apparatus needed for our second design are the same as our first design, where firstly, we will use the plastic cylinder Tupperware, where we will be pouring our water sample in it. Then we'll be making 3 holes under the plastic cylinder Tupperware with a diameter of 2 cm each by using scissors and cutter. So what's different between our second design and our first design is that in this second design we'll be increasing the height of fine grain soils, which will be increasing from 5 cm to 10 cm. And then as for the height of gravel, we will be keep it the same as our first design with 5 cm. Then we'll be using this piece of cloth to cover the bottom part of our plastic cylinder Tupperware. So we will attach the cloth and the plastic cylinder Tupperware by using some rubber bands. So without further ado, let's get started. So firstly, we'll make marks under the plastic cylinder Tupperware. So we'll be making 2 cm diameter of holes. So we'll mark the length of 2 cm for each hole. Then these marks will be our guidance when we try to make holes under the plastic cylinder. So these are the marks. So the next step is to make holes under the plastic cylinder Tupperware. So we'll be using cutter and scissors. So we follow the marks that we have done before this. Try to cut the hole. Alright. So this is one of the holes. So repeat the same step for the next 2 holes. So the next step is we'll be going to cover the bottom part of our plastic cylinder Tupperware with this piece of cloth. So to do this, we have to make it like this. Then we'll be using some rubber bands. Just stretch it like this. So repeat the step with the other rubber bands. So the next step is we'll be pouring the fine grain soils into the plastic cylinder Tupperware. So I will pour it until it reach 10 cm height, which you will measure it by using the cylinder. So just pour it as usual. After done pouring all the fine grain sauce into the plastic cylinder Tupperware, so we have to measure the height of the fine grain sauce. So make sure that the height is 10 cm, and as for this, the height is already 10 cm. So we will proceed with the next step, which is pouring the gravels into the plastic cylinder Tupperware. So we'll pour the gravels until it reach the height of 5 cm. After done pouring all the gravels into the plastic cylinder Tupperware, so before proceeding with the next step, make sure to measure that the height of gravel is 5 cm. And for this case, the height of gravel is already 5 cm. So in front of me is a water sample. We'll be pouring this water sample into our second design of water purification system. So we'll pour it. So we have to wait for 40 minutes to get the results of our filtered water.
Assalamualaikum and hi. My name is Muhammad Shauki bin Izham. I am responsible to make the third model of water purification system. This model is just the same as the first model and second model, except we changed the depth of the fine sand to 15 cm. As the model design is just the same, so the material that we need is Tupperware, a piece of cloth, gravel, fine sand, scissors, cutter, and also rubber band. So first step of making the third model is we have to mark 2 cm diameter at the bottom of the Tupperware and make a hole with cutter. Okay, after the bottom of the Tupperware is cut, we use piece of cloth to cover the bottom of the Tupperware. After cover the bottom of the Tupperware with piece of cloth, we use rubber band to make sure the cover does not fall off. So the next step is we add the fine sand in the Tupperware. After the bottom of the Tupperware is cut, we use piece of cloth to cover the bottom of the Tupperware. After cover the bottom of the Tupperware with piece of cloth, we use rubber band to make sure the cover does not fall off. Okay, so the next step is we add the fine sand in the Tupperware. Okay, after we have add the fine sand into the Tupperware, now we will add the gravel.
So make sure the depth of the fine sand is 15 cm, where the gravel is 5 cm. So now the third model design has complete.
The filtrated water is obtained from 3 different filters. The water parameters that we would be analyzing on are turbidity, pH level, and color and order. Turbidity is the amount of cloudiness in the water. Turbidity often indicates the presence of dispersed and suspended solids like clay, organic matter, silt, algae, and other microorganisms. In drinking water, the higher the turbidity level, the higher the risk people may develop a disease from drinking the water. Materials you will need are a turbidity chart, water samples, and a clear plastic cup. For the procedures, fill the clear cup with the sample. Place the cup over each circle starting with 0 JTU, Jackson turbidity unit, on chart. Look down the cup, and if you can distinguish between the dark and light sections, move to the next circle. The first circle you can no longer distinguish between the light and dark section is your turbidity reading. If you can distinguish between the dark and light circle in all the circles, then you have mostly clear water with little turbidity. Repeat for the other water samples. 0 to 20 JTU indicates stressful for some fish due to lack of food production. 20 to 40 JTU indicates aquatic insect production slows. 40 to 60 JTU, algae and zooplankton production drops. 60 to 80 JTU, less light reaches plants, which photosynthesis slows down. 80 to 100 JTU, little effect on aquatic plants and animals. For drinking water supplies, the following guidelines should be taken into consideration. Drinking water should have a turbidity of 5 NTU or nephelometric turbidity units JTU or less. Turbidity of more than 5 NTU JTU will be noticed by users and may cause rejection of the supply. Where water is chlorinated, turbidity should be less than 5 NTU JTU and preferably less than 1 NTU JTU for chlorinication to be effective. For pH tests, pH is a measurement of electrically charged particles in a substance. It indicates how acidic or alkaline, basic, that substance is. The pH scale ranges from 0 to 14. 1 to 3 indicates a very acidic substance, 4 to 6 indicates an acidic substance, 7 indicates neutral, 8 to 11 indicates alkalinity, 12 to 14 indicates very high level of alkalinity. For the procedures, simply press the testing strip into the water sample. Half a second later, take out the paper and using the color chart included, compare the color change of the paper to find out the pH level. The test strip color changes must be matched with the pH scale color chart within about 15 seconds. And repeat for the other water samples. For color and order, drinking water should ideally have no visible color. Most people can detect color above 15 true color units or TCU in a glass of water. Levels of color below 15 TCU are often acceptable to consumers. Taste and odor in drinking water may be indicative of some form of pollution or of a malfunction during water treatment or distribution. Taste and odors caused by disinfectants are best controlled through careful operation of the disinfection process and pre-treatment to remove precursors. The procedures: observe the color of water sample and sniff the water sample to check the odor.